Okay, please go ahead and return to your seats, and we will just discuss a little bit more. Okay, so we looked at a two-way table, and we looked at just looked at a few questions that sound similar, okay, but are also distinctly different, right? What percentage of students are brown-haired males versus what percentage of males have brown hair versus what percentage of brown-haired students are male, okay? These all sound kind of similar, but they're also very different, and we have to be able to read a question like this and understand what it's asking. In your homework, you're going to have a few problems that go through similar questions like this, okay? But they sound even weirder, okay? One of your homework problems talks about this change and don't change, right to wrong, wrong to right. And the wording is funny, okay? And I purposely assigned that problem so that you can, I don't know, wrestle with, reading through the problem and understanding what it's asking, okay? And there's so there is some of that, okay? And some of you, I know we have some international students where English is not your first language, and in statistics we're dealing with a lot of word problems, okay? And so it might be a little bit of an extra layer of struggle that you might have to face, okay? And that's just part of the course, okay? Is that there's a lot of word problems that you're going to have to sift through, and so please, as you work through these homework problems, take your time, read through this, and make sure you understand what the question's asking, okay? And if it still doesn't make sense, you can post a question to the Facebook group. You can look at the video and answers that I posted online. All right, so we've talked about categorical data, and we also have numeric data, and we'll talk about summarizing numeric data maybe next week. But we'll look at some data displays. I'm going to just summarize a couple things. There's a few points that you're going to have to do in your reading. Okay, so part of your homework is to do reading in chapter 1. Okay, actually read through all of chapter 1. But especially, we're going to just gloss over a small section right now during our lecture. And this is on the difference between an observational study versus experiments. Okay, and you're gonna have to read up on the difference between observational studies and experiments. Okay, and I'm just gonna summarize just the brief bullet point. Okay, the idea is that in observational studies we observe and do not interfere with the subjects we study. Okay, we do our best not to interfere with the subjects we study. And the thing is from an observational study, you can never draw a cause and effect conclusion. Cause and effect relationship. So if you observe something, just because two things seem to happen together doesn't mean one thing causes the other. Okay? In an experiment, on the other hand, we assign treatments to the participants. And we try to control as many aspects of variation as possible. And if the data support it, we can draw the cause and effect conclusion. This is a very, very, very brief summary of observational studies versus experiments. It is your responsibility to do the reading and learn more about observational studies and experiments. There's a few questions in the homework about it, okay? You'll learn about, you'll see words like placebo, things like that, okay? All right, and if you have any questions from the reading or things like that, again, post your questions to the Facebook group. And other students, you may answer each other's questions, and I'll assign bonus points to good answers, okay? Okay, all right, so let's, that wraps up chapter 1. Chapter 1, there's a few other topics again. I think the beginning of this class starts off really, really, really easy, okay? And so this first week might feel really boring. I promise it picks up, okay? And it gets more exciting and more challenging. And you should all look forward to it. But this first week, it's really easy. You got a few things you're gonna have to read about in your homework. A lot of things, it's kind of like, do you know how to do proportions and percentages, and do you remember this stuff from algebra, okay? And if you do, it should be a piece of cake. And if you don't, then this is the week to learn algebra and brush up on all of that stuff, okay? I've got a few on the homework page, and also on the resources page on the website. There's a page called Resources. I link to a few videos from Khan Academy, which go over some algebra concepts. Some of you probably need to review that stuff, okay? So if you feel like you've struggled with math this week, while the stuff is easy, work hard on getting yourself up to speed so that you don't get lost in the future, okay? Because by the third or fourth week, by the time the third or fourth week rolls around and you realize, oh, wait a second, I'm struggling, every week there's more stuff to learn, and you're going to have to try to catch up on all this other stuff. So in the beginning, while it's easy, now's the time to catch up if you need to. All right, so anyway, we're going to move on to chapter 2. We're going to cover the first bits of chapter 2. And we start off with displaying data, okay? Displaying Okay, so if you are not shy, let's gather some data on our students here, okay? Completely optional, but tell me, you don't have to do this, but just tell me, raise your hand, say, I am male and I am this tall, okay? Give me your height in inches, all right? So if you're 5 feet tall, oh, for those of you who are international and not used to their stupid customary system, there's 12 inches in a foot, okay? Oh, but of course, if you're international, you don't know how tall you are in feet and inches anyway, right? So anyway, 12 inches in a foot. So if you're 6 feet tall, you're 72 inches. If you're 5 feet tall, you're 60 inches. If you're 5 feet 4, you're 64 inches, so on and so forth. Okay. Just call out, say, female this tall or male this tall. So somebody just, yes, go.
Female 67 inches.
Okay, female 67 inches. Who's next?
Female 65 inches.
All right, 65. All right, next.
Male 75.
Male 75. Great.
Male 71.
Male 71. Keep coming.
Female 51.
Female 51. Wait, 51?
61.
61. Okay, nothing's wrong with being 51 inches, but that is unusual. Okay. Okay. Next.
Female 61.
Female 61. Okay. Male 63.
Female 60.
Female 60.
Female 65.
Female 65. Female 58 or 68? 58. Okay. All right. Okay. Well, that's good enough. Okay, that's good enough. So we have collected two things, two variables. Sex is categorical and height is numeric. Okay. All right, and I have data on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. Okay, that's great. Okay, so my N is 10. N is your sample size, or basically the number of data points you have. The number of numbers or data points. Okay, so if we wanted to display our numeric data, there's all sorts of stuff we can do. First, one basic thing is called a dot plot. Okay, so we're going to make some graphs to display our numeric data. Okay, because it's numeric data, all graphs and charts and plots or whatever from numeric data, you always have to put a number line across the bottom. Okay, always put a number line. Okay. And we've all used number lines, right? For a number line, small numbers go to the left, large numbers go to the right. Okay? And you guys smile or laugh, but sometimes students, they just put like numbers in the wrong order. Like, no, please. Okay. So anyway, we're going to start off. We look at this. So it looks like our smallest number is 58. Okay. Wait, if you're 4'11", you're 59 inches. Is that what you meant? Yeah. Okay. Although 58 inches is 4'10", and there's nothing wrong with that either. Okay. But okay. So we got 59. 60, okay, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. Okay, and that seems to be the highest number we have. Alright, and so here, we're going to, with a dot plot, we just go and we put a dot for every single number we see. So there is a female, 67 inches, and put a dot right there. Another female, 65 inches, male who is 75 inches, male 71 inches. Is this okay? The way am I putting these dots on too quickly? We're okay? Okay, so here's a male 71 inches, so I put his dot right there. Okay? And here's a female 61. Okay, so see if you can fill out, put the other 6 dots on your thing. Oh, I guess I need to point this out. If you have more than one person at the same point, you just put the dots above each other, okay? So you got 61, 61, and then you got 4 more, because I've done 6 of these for you. Okay, and it should be quick. It shouldn't be too hard. And everybody should be making one of these. Okay, so then I've got a dot at 63, a dot at 60, a dot at 6, another dot at 65, and a dot at 59. Okay, is that what all of our dot plots look like?
Yeah.
Okay, great. So I've got 1 dot for each student. I've collected the data on 10 students, and this is what my dot plot looks like. Okay, it's not very exciting, but this is one way to display the data, okay? And when we see data like this, we already get an idea. We can say, oh, it seems like, you know, we've got quite a few students down here, okay? And that's because our class is, it seems like mostly female, okay? Maybe, there's males, of course, and it's probably like a 60-40 split. And whatever, the males didn't volunteer their information as readily as the females did, whatever. Okay. Who knows? Alright, and so we have, this is what our data looks like. Okay, this is a dot plot. And you can imagine, okay, that had we gathered data on every single student, I said, how tall are you? Your grade depends on it. And everybody gave me their height. Okay, so we have a lot more data points. Okay, so this is like, you know, this is for n equals 10. So if we had a lot more, okay, and so maybe we would have a lot more dots. Okay, I'm just making up a dot plot here. Who knows? Okay. Alright, so this is with more students, and I've just made up some more ones. Okay? And so with something like this is still a dot plot. Okay? It gives us kind of an idea of the range in heights that we observe. Okay? Some students are tall, some students are short, some students are in between. Okay? And it seems, what would you say is kind of like a middle-ish point? Middle-ish height.
5.
Yeah, 65, 66 inches, something around here. This seems to be around somewhere around here seems to be middle-ish, okay? And we will define the idea of center a little bit more later, okay, actually next week, okay? But this kind of gives us the idea of, you know, kind of what's in the middle, and it also gives us an idea of the amount of variation, or the amount of spread that exists, okay? So if you see something like this, you know, let's say you knew nothing about how tall people are, okay? But you say, oh, this is a, you know, let's say you're from a country who's never heard of feet and inches, okay? So someone says, oh yeah, these are the heights of my students, and you're like, what units are these, okay? Very, actually, I would not be surprised if that happened. And, but if you saw this, and then you said, oh, you know what, the other day I saw someone, and he was 83 inches tall, you'd be like, oh, wow, that's tall, okay? Because everybody in this class was nowhere near that, right? 83 inches, that's way out here. 83 is what? 6 feet 11, okay? That's pretty tall, okay? Or, you know, if somebody says, oh, you know, I saw someone who was 68 inches. You go, oh, that sounds average-ish, maybe a little bit higher than average or whatever, okay? Something like that. So the dot plot gives you an idea of, so these graphic displays, okay? Gives you an idea of where the middle might be, as well as an idea of the variation, okay? And you can imagine, let's say we went through history records, and we said, let's find out how tall all of the, I don't know, how tall the members of the, I don't know, women's gymnastics team are, okay? So we go through, I don't know, the Olympics, and we say, how tall are you, okay? And, so how, you know, what would the women's gymnastic team look like? How tall do you think these? They're pretty short, right? They're like incredibly strong, but they're also pretty short, and they do like a billion flips, and everyone's like, whoa, okay. Okay, so probably like we got a bunch of people who are, you know, 4'10", 4'10" to 5'2" ish. Okay, you don't see too many people outside of that range, and so if you look at heights of the women's gymnastics team, it might look something like this. Okay. And so seeing this here, so this is maybe women's okay. This gives you an idea. What do we see? We see, again, we get an idea of middle-ish, something around here. And the amount of variation that we see here is less than the variation over here, right? So the middle has a lower value. So this is around 60. And the variation is less too, okay? Variation or spread in numbers is less as well. Can we see that? Yes, question? Oh, I said around 60. Around 60. Yeah, you know, those of you who are sitting in that back section, I encourage you to sit in the front section because, I don't know. You're closer to this. You're closer to the front of the class, and historically. And this is not a cause and effect thing, okay? This is just something I have observed, an observational study, per se. Students who sit closer to the front tend to do better than those who sit in the back. It's not a cause and effect thing, so moving around may not change your grade or anything like that. But, I don't know. Who knows, okay? Students who come to class tend to do better than students who don't come to class also. I don't know if that's cause and effect. And, all right, whatever. Okay, so that's a dot plot, okay? Now, we see here, it could get annoying to have to draw these little dots here, okay? And you might not even like looking at dots, okay? So we have something called a histogram. And basically, we replace the dots with bars. So that dot plot might end up looking something like this, okay? Again, because we're still dealing with numeric data, okay? Still dealing with numeric data, we got to put a number line across the bottom. And so the way this works is that 59, there was one dot. So I'm going to have, along the left-hand axis, I'm going to have a vertical axis that indicates the height of the bar, how many dots there should be, okay? And so at 59, I had one individual, and at 60, I had two. So this goes up to the second line, and at 61, there were 4 people. So this goes here, and at 62, there were 3, so on, and this goes on and on, okay? And you fill out the rest of the bar. Okay, and it looks something like this. All right. Basically, you replace the dots with bars. With bars of the appropriate height. Okay. And there we have a histogram. Is that okay? Okay. And actually with histograms, you could have, in this case, each bar represents one number, but you could change it so each bar represents maybe two numbers. And then your bars would get taller because you'd have more numbers than, you would have fewer bars, but more in each range.
They all have to touch each other.
Yeah, the bars touch each other, okay? Unless there's no number in that spot. Okay, so that's a histogram. And when we create histograms, okay? Well, actually, let me just check how much time I got. Okay, so we can actually, you'll see it in the textbook. We can change the width of the bars. And this is a histogram, and it's for numeric data. All right, when we have all these different, some histograms we've got, we have different names for the shapes of the histograms, okay? So you could just imagine, this would be like a textbook example, okay? We could have a histogram that looks like this, okay? And some might even summarize this histogram with just a curve that looks something like that, okay? We describe the shape of this histogram as being unimodal, which means one peak, and symmetric. Okay, so there's two words that we use to describe it: unimodal and symmetric. Okay, one peak and symmetric, meaning we see some symmetry. Again, in histograms, the bars touch. All right. So what does it mean to be unimodal and symmetric? This is something where you have a middle and you have just about as many people who are above the middle as you do who are below the middle, okay? So actually, if we look at just one gender, height is generally unimodal and symmetric, okay? So the average height for women is something around like 5'4.5", okay? And we have You have some women who are taller than that, some women who are shorter than that, okay? But you have just about as many people who are above that as you do below that. Okay? On the other hand, we can have a histogram that looks like this. Right? And if we summarize this with a curve, it might look something like this. Is that okay? And this, how many peaks does this have? One. So this is still unimodal. So one peak. But this is not symmetric, this is skewed. And we would say this is skewed right. Okay. Because the side that looks like a skewer is on the right. Okay. So if you just imagine if you're going to cut this out of the board and stab some meat with it, the side that you would use to do the skewering is on the right, so this is skewed right. Okay, remember, this is still numeric data, so what might be skewed right? Or what does it mean to be skewed right? Yes, we have a question.
If everybody is like 65 and one is like 60, what is the peak?
Huh?
What is the one peak?
One peak for this one?
No, I mean, I'm giving an example. For example, everybody is like 65 and one is like 60. What is the peak of this?
Like everybody is 65 inches and
yeah.
one person is 60 inches?
Yeah.
So in that case, you would have everybody is at 65 and one person is at 60.
Yeah.
So the peak is over here.
But everybody is like 60. More than one people.
I think we might be confused on something. Let me
No, I mean if
address
everybody is like maybe it's
then everybody
sorry,
is not
sorry.
65.
So there will be only one peak, right? Every time. It can be.
You know, let me continue here, and then
Okay.
I'll try to address your concern there. Okay. Okay. So we've got so in this case with unimodal and skewed right. Okay. So remember, this means. What does it mean? This means most people, okay? This means that this particular value, whatever this value is, maybe it's 150, okay? At this value, there are a lot of people who have this value of the numeric variable that we're talking about, okay? And if we go a little bit above it, we've got some people, okay? And if we go below it, we still have a lot of people, and if we go further below that, we still have a good amount, but then if we go further this way, we don't have anyone, okay? However, if we go in this direction, so if this is 150, maybe this is 190, and this is, I don't know, 230 or something like that, okay? As we go further and further away, there are fewer and fewer people, okay? Okay, because 5110. So this could be something like weight, okay? So maybe this is female weight, all right? Average weight in the U.S. for adult females is like 145 pounds, okay? And if you go further to the left, okay, yeah, we got a lot of women weigh like 120 pounds or 100 pounds, things like that, okay? But you hardly have any women who weigh much less than 100 pounds, okay? Maybe 90 pounds, but adult women, you certainly won't find any adult women who weigh like 20 pounds, okay? That's just not possible, right? Okay, so if our middle-ish is around, let's say 140, 150 pounds, okay, we have nobody who's, let's say, 100 pounds less than middle. Okay, so 100 pounds less than middle would be 50 pounds. We have no adult women who weigh 50 pounds, okay, or hardly any. On the other hand, if you go 100 pounds in the opposite direction, that takes us to 250 pounds, okay? And there's a number of women who weigh 250 pounds, okay? And so there are people, there are women who weigh 250 pounds, there's women who weigh 300 pounds, or things like that, okay? Who weigh considerably above what we might consider middle, okay? So we have people who are considerably above the middle, but if we go that far down below middle, we have no one, okay? So yeah, are there women who weigh 300 pounds? Yes, not a lot, but there are, okay? And so if we say average is 150, 300 pounds is 150 pounds above average. If we go 150 pounds below average, that takes us to 0 pounds. Are there any adult women who weigh 0 pounds? No, okay? And that's what skewed right means, okay? It means we've got kind of this middle-ish area. We've got some, not a lot, but some people who are far to the right. But if we go that far to the left, there's no one. Okay, so skewed right. So there is a quote middle. Some people who are much higher than average or middle, but no one who is that far lower than average. Okay. Is that okay? So that's skewed right. And so, what do you think this is called?
Skewed left.
Skewed left. Okay, unimodal. Sometimes we have more than one peak. All right. This is called bimodal. This might be testosterone levels in people. Okay. All right. Everybody produces some testosterone, okay? Men generally produce, men produce more than women, not generally, they do. And so you would see something bimodal, okay? Where this might be the average amount of testosterone that exists for a male. Some males produce more testosterone than other males. Some males produce less testosterone than other males, okay? And so that's represented in this thing. And over here, we have maybe the testosterone amount for women, okay? Average. Some women produce, the average amount of testosterone is here. Some women produce more testosterone than other women produce less testosterone than other women. And you get something that looks like this. This would be bimodal, okay? Okay, if you have more than 2 peaks, I guess you could say trimodal, but generally we just say multimodal. Anything with more than 2 peaks, this would be multimodal. And then sometimes you have something that looks like this. Okay, this is called uniform, and this pretty much says all values are equally likely. Okay. So this might be, what is the last digit of your cell phone number? Last digit of your phone number, okay? We probably have just as many people whose last digit is 5 as we have people whose last digit is 9, whose last digit, and just as many people whose last digit is 2, okay? So each of those numbers 0 through 9 probably show up just about the same amount. Okay, that's still it's still a numeric variable because it's 0 through 9. Tells us what's your last number, and each one shows up equally often. Okay, so that would be a uniform distribution. Okay, you're gonna have to do some reading on this stuff, okay, and do your homework problems. Again, please do the homework problems, work through them, and but you will keep the homework yourself and turn in that paper. Now, I hope this works. And so please be honest. Okay, we'll see you guys next week then.